Hi there, welcome to my channel once again. Today we are going to look at building a software application, and a case study would be on a bus booking system. Now, there are various steps involved in database development. One of them is gathering requirements. Then we have to go ahead with the design. And design is also similar to, can also be called data model mapping. Then we talk about implementation. After implementation, which is where we code, we now test and debug for any errors before deploying to the user. Now, in gathering requirements, what usually happens is that we get to the firm and you ask your clients the kind of documents that they have in the office. It could be a register, it could be a ticket, it could be an invoice, whatever that could help you understanding how that business works. You need to ask questions. In the process of asking questions, you will understand what they need, and you would tend to be able to solve your problem better, because sometimes your client doesn't really know everything about what they need. Now, you also choose your database management tools and your programming tools. You need to be sure of that before you move in proper. Now, let's look at the design phase. Now, let's have a scenario here where we had gotten the documents from our client and we saw their register, and it was filled with maybe it could be a book that was filled with pen and paper. Now, that book has a serial number, a date, passenger's first name, the last name, the phone number, the sex, the age, the address, the next of kin, the kin's phone number, from where the passenger will be traveling from to where it's going, destination, the price paid, the fleet number, the vehicle plate number, and the salesperson for the day. Now, in this register, if you look at it, you see some issues which we would have to resolve. Now, we saw MacDean. MacDean traveled on the 12th of November and also traveled again on the 15th of November. Now, on the 12th, MacDean, with all his details, the same phone number, age, also here the same number, age, traveled from Abuja to Lagos and paid 10,000 naira. Entered a vehicle, fleet number 121, and registered by Peter Allison. Now, MacDean traveled on the 15th and went to Abuja to Uyo, paid a different fare, 12,500, a fleet number 333, and was registered by John Udo. Now, that creates what we call a repetition. Okay, that means each time you need to fill this form, you must enter MacDean's detail completely again, which means if MacDean uses within a month or within a year, he has to travel about 50 times in this company, because some guys who are sales reps do travel up to that amount of time, then he has to be registered here completely like that every time, and that tends to drag and delay the registration process before the person travels. And this is for a company that is actually keeping tab of its clients, because sometimes it could be because of your number of travels, you may be able to enjoy mileage and have some maybe rebate on your fares due to your patronage. We also have the same thing with Colesman. Colesman has traveled also on the 12th, and he traveled from Abuja to Lagos, and then on the 16th we traveled from Abuja to Calabar. Now, Coleman was registered by Nokun here, whereas here was registered by Peter Allison, right? Now, you would see that we want to confirm this Coleman and this Coleman are the same, and we found out yes, the same names, their numbers are the same. This is male, this is male. 10 Herbst Road, yes, the same Herbst Road. Phone numbers are the same, they have the same kin, which is Rodgen. So which means they're the same people. Now, there's a possibility that we could have the same name, but they are different people. We don't have that scenario here. Now, there's another issue. You have the sex column. You tend to have male in capital letter. Some people write in small letter. Some write in full, like John Udo writes it in full, while Peter Allison tends to be writing everything in just one letter. Now, you can notice that that is a difference, which means on this very register, whoever uses the register at a certain time we tend to document it differently, and this creates some problems of repetition, redundancy, and does not really give quality, integrity to this document. So the reason why we have to build a database is to increase data integrity and also to help us to ensure that we don't have lots of repetitions and redundancies. So what do? The first thing we have to design, we have several processes involved in designing. One is the relational model, we have the normalization, we have entity-relational model, and we have the user interface design. Now please, I want you to note that we are still talking about relational model of database development. So we are actually going to use a relational database management system over here. All right, there are several relational database management systems, and I believe you watch another video of mine to see the types of RDMS that we have. I'll leave the link somewhere up here so that you can have a look at that. Now this is a diagram using UML notations. UML means Unified Modeling Language. You know about Unified Modeling Language in one of my other videos. Now the ER model has several parts. Here is the entity, and this is the relationship between two entities, and then we have this relationship is like many to many relationship between these two entities, and supplies, there must be at least one supply, but there can be no item on a supply. And that's kind of what is happening here. So we'll go into details about how the boss system works. All right, so first and foremost, when we looked at our table, we gather all the column names and attributes of the booking register. Now we remember that we saw date, we saw passenger first name, we saw the last name, the passenger phone number, the sex, the age, the address, the next of kin, the kin phone number from where to where, price paid, vehicle fleet number, plate number, and the salesperson. We saw all these on that table, so we can take a look at it again. You see it here. We have all that, the date. The only thing we don't really have there is the serial number, okay? But we have all the basic details. Now we do that. Now if we need to be sure what is an entity, okay? Now an entity is a possible table. Another word without beating around the bush is to say that an entity is actually a table. All related data will be put together into one table, and we call it an entity. So what are the possible entities or subjects in transport company, in any transport company, or from the register which you have seen? Now one of them is that there will definitely be passengers, there will definitely be a destination for the transport to go to, there will definitely be vehicles, and definitely there will be staff that will handle the booking. Then these are possible entities in each of these databases that we're going to design. All right, let's dive into the next. Now we are looking at a relational model here. This is a relational model of the booking register, and the way we write relational model is by write it in a word format. You can see it here, booking register, and then in bracket I put all the possible columns that were on that table. Now another name for these columns is attributes. So you can see here I said column names or attributes, so take note of that. Now normalization. What's normalization? Normalization is the process of breaking down the big register table into smaller related tables in order to reduce data redundancy and improve data integrity. I had told you that the main essence of a database is for us to build a software that will increase data integrity and reduce data redundancy. We don't want people to type in or write in more things as if we are working with Excel and keep repeating things over and over again. We are not working with a spreadsheet here, we are working with a database. So from the small tables, we can get entities and their attributes. Now we have normalization has different types. We have what we call first normal form, second normal form, third normal form, Boyce code normal form, and we have fourth normal form, and so on. Now there's a video also I've done on different types of forms, all the forms, and then here we are going to break down all those forms, use all those forms in this software, so you see how they are being applied. Okay, now, so the first normal form, it means that a relation should meet the conditions for a relation. Now remember, a relation is something like, we could say, a table. All right, a relation should meet the conditions. In fact, what it means is that the conditions, there are 6 conditions usually, but the 6 conditions actually more of deal with atomicity and having a primary key. You should have a key element that will identify an entire row, and then you also have atomic values in each of those columns. So we look at, first and foremost, we say that each row must be unique with a primary key. Each column must have a unique name. Now, having a unique name means that you can't have 2 columns having similar names. They shouldn't perform similar functions. So that's what we mean by atomicity. All right. Now, a column value must have a single value only. Yes, single value only. We don't want multiple values on one column. Each column value must be of the same data type. Okay, remember we have several data types like the string, we have string text, numbers, we have characters, variable characters. They are diverse, Boolean and all of them. Okay, so what we want here is that each column should have only a single data type. Then the order of rows does not matter, and neither does the order of columns. So noted here is that the primary key is a unique column that identifies an instance of a record. So the primary key in one table can be inserted into a related table, and we call it a foreign key. So usually if a table is so big and you need to break it down, when you're breaking it down, you can pull out the primary key from one table, put it into another table, and you have it there as a foreign key, and automatically it gives you a relationship between the 2 tables. Okay, so let's say here in this table we decide to add back that serial number. Okay, we added back the serial number, and the serial number will act as our unique key. Remember, serial number, we could use an incremental number, auto incremented, which means you have 1, 2, 3, 4, 5. It automatically increments as it goes on, so that no serial number is the same. Okay, now that's one way of solving it. So once we put the serial number, as you have seen here, serial number is on this table, then automatically it puts it in first normal form, 1NF. Now we have been able to make each row unique. All right, so even though we have MacDean here twice and MacDean here, but the serial number is 1 and the next one is 10. We have Colesman twice, but the first serial number of Colesman is 3 and the second serial number of Colesman is 11. All right, so now that is the easiest way to handle first normal form. Once you can get a primary key, you can get it to be your first normal form. Now another way to handle it is we could decide to say, let's have what we call a composite key. Okay, there's another video which I have done that will explain what are composite keys. Okay, right. So now let's say you want to have a composite key. We can decide to use the date, we can decide to use the name of first name, the last name, and the phone number. Now we can have a combination of those, the date, the first name, the last name, and the phone number, to act as our composite keys. So the moment the day he arrived, his name and his numbers, those 4 values can act as a composite key for him, because definitely we know that MacDean is traveling from one place to another. But let's say MacDean travels, maybe he uses a company to travel from one place to another that day and comes back that very day to travel on another place, and he uses that to go to and fro, which means MacDean can make 2 or 3 journeys in one day. That's possible, isn't it? Good. So since that is possible, we can also add MacDean's from to. Where is it coming from and where is it going to add also as a primary key, which means we can end up having 1, 2, 3, 4, 5, and 6 different columns to act as the combined or composite primary keys, which we always call a composite key, okay, because we are combining several keys. But usually, as we move on in this development, you will see why sometimes those issues and such information may not be very good. That's why we have to sometimes generate a single unique value to act as our primary key. Now, the second normal form. Second normal form says that in second normal form, all non-keys must rely on the primary key or keys apart from the foreign key. Okay, now what do I mean apart from the foreign key? Remember, the foreign key will be coming from another table, so definitely even if it repeats and does not rely on the basic primary key, it is not a problem, because already it's relying on what? It is relying on its own primary key table. The foreign key is actually a child to this table. So from the following data are related and should have a primary key. For example, we have the passenger. Everything about the passenger's first name, last name, his phone number, sex, age, address, next of kin, and the kin's phone are all related. So we put that under the passengers table. Now, automatically, second normal form says that all non-key must rely on the key. So remember, we use serial number as a key. But when we are forming a table with this, I decided to say, let's use the passenger's phone number as a primary key, and then relate all of them to the passenger's phone number. Okay? There's a reason why we are using this, because we expect that every passenger should have a phone number. Every passenger should have his own unique phone number, and once you have your unique phone number, you know 2 passengers have the same number. Now, even if a child wants to travel, he's going to travel based on the parent's phone number. Okay, any underage person that may not have a phone will travel based on the parent's phone number. That's what we assume. So the phone number can act as the primary key. Okay, so everybody relies on it. Now we also have destination. Destination, we had from, to, we had price paid, we had the vehicle fleet number, we had the vehicle plate number. Now I decided to use the vehicle fleet number as a primary key because the vehicle fleet number was unique on that table. Now let's go back and have a look at the table, and you will see where the vehicle fleet number was. Now look at it. The fleet number, we had 121 was related to 12AX. Okay, you can see that 12112AX. Then we have 504 related to 34CB. 333 is the same thing as 13YY. Okay, so 451 relates with 25AB. So the vehicles are going to have, we go with their plate number. Okay, so from 2, you can also see that here Abuja to Lagos is handled by 121, when we have Abuja to Calabar handled by 504. Then we have Abuja to Calabar can also be handled by 451 and 25, which means we have about 2 vehicles that are going to Calabar. All right, now that creates our fleet number. Then we have the staff. The staff also is on his own. He doesn't belong to the destination or to the passenger, so we give him his own table. All right. Okay, so they should be separated into different entities and the attributes added where necessary. So you can have a look at the table after splitting it here. You see this table, you notice that we have deleted the second repetition of Mark Dean, and we have also deleted Goldsman. You may ask why. Because instead of us to keep typing in this detail anytime we are going to build that register, it's better if we look up at this table to relate it with the destination the passenger is going to. All right, so that will create that same table. If I were to say Abuja to Lagos, and I was to select MacDean and attach Abuja to Lagos, Basibul, Coleman, Rothman, automatically Abuja to Lagos is going to have 3 entries. Okay, you're going to have 3 entries. You can see that here. Okay, see that here. MacDean, Abuja to Lagos, Basibul, Lagos, Coleman, Abuja to Lagos. Now you have these 3 guys already going to Lagos. Okay, 3 of them going to Lagos. So it has moved from 1 MacDean or 1 Abuja to Lagos to 3 Abuja to Lagos, or even 4 Abuja to Lagos. Okay, so we have to separate that. So passengers are all 1, so we have unique. Each row is unique. There's only 1 MacDean, and if there's another MacDean on this table, then it's definitely not the same MacDean. We will make sure it's not the same MacDean on this table. Then we also have the vehicles destinations. So we have destinations vehicle table here. So this tells you Abuja to price paid, vehicle fleet number, and the vehicle number. Now we use phone number as the primary key here. Remember that, recall we use. So this is why you have the phone number here. Then we use the passenger phone number here as the primary key. Okay, that's what we did here. Now for destination vehicle, we use the vehicle fleet number, from, and to as composite keys to be able to handle that. So if we do that, we see that they are all unique, because all the 10,000 is dependent on Abuja to Lagos. 10,000 depends on Abuja to Lagos, while 12AX, all right, depends on fleet number. So we have split our tables together, and we make sure that all the non-keys rely on the keys. So these are, we have 3 keys here. This one relies on this key, Abuja to Lagos key, while vehicle plate relies on vehicle fleet number keys. Then salesperson can actually be a key on his own, so he has no problem. Okay, now we move on to the third normal form, 3NF. 3NF says that there should be no transitive dependency. For example, what is transitive dependency? Once one value can determine a value based on another value. Now that's transitive. Okay, that means that we can have confusion somewhere, and we can have redundancy somewhere. Now let's look at the scenario here. If A functionally determines B, and B functionally determines C, therefore A functionally determines C, right? So let's look at that here in this table. Destination table has transitive dependency. Vehicle number determines the fleet number. So if 12AX, the plate number 12AX automatically determines the fleet number 121. 34CB determines 504. 13YY determines 333, while 25AB determines 451. You can see that. So that means that these two, even though this guy plate number relies on or depends on vehicle fleet number as its key, but it doesn't depend on these other guys as its key. So we can have them pulled out, because which means there's always going to be a redundancy here. Anytime there's 121, there's going to be 12AX. Now let's go back to the major table and you see where such things are happening. All right, now let's take a look at this. Sorry, you see this 121 12AX, 121 12x 121 12x 121 12x. See that there's repetition going on, and we don't want this repetition to continue in our table, because that will mean lots of repetition. Anytime the receptionist, the cashier, the salesperson wants to go ahead and enter values for the fleet number, he must also enter values for the plate number. Okay, why do we have to allow such repetition? Why don't we just go ahead and give him an opportunity to enter just 121 and 12x once, and then anytime he needs such values, all he has to do is to look up at the vehicle table and get the value of the fleet number, and automatically that will bring up any other information needed about the vehicle. Okay, so we need to split that table. So the vehicle plate number determines from, to, and price. Okay, so we have here that the vehicle plate number determines the fleet number, the plate number determines the fleet number, and the fleet number determines the from, to, and price. All right, in this very information here, fleet number, from, to, and price. We also have an issue here where the fleet number determines from, to, and price. Okay, and that, even if you look at this, it now creates some problems, because definitely it doesn't belong there. So what we need to do is to split the destination table. So we split the table into destinations and vehicle tables. Okay, split into destinations and vehicle numbers tables. Now destination vehicle table look like this. Remember, we had 1 2 3, these three, we will split it, and we have destinations. So we have from, to, price paid. You can see Abuja to Lagos 10,000, Abuja to Calabar 15,000, Abuja to you 12,500. This leaves everything about destination here, and there's no more transitive dependency here. All right, then we have vehicles also having their own issue, where we have 121 12x 504 333. So we have 4 unique vehicles here, and the vehicles are very well on their own. Now you can find out this table had 4 columns. There were repetitions here about Abuja, Calabar, but now that is not done here, because we are only talking about destinations. Okay, so if we combine these two, we have a one-to-many relationship here, which sorry, a many-to-many relationship here, and most times we try to avoid many-to-many complications. Okay, that's one of the rules in database development. So we have had this destination table where we said that from and to are the primary key of this table right now. These two are the primary key of this table, and this is the primary key of this table. Okay, so these two, from and to, are combined to form a composite key, combined key. Right, so we now want to go to the final relations. Okay, now there is a possibility that we can have a final relation, but it won't have to be exactly like what we just designed. Why? Because remember, we had several composite keys. Destination, we had from, to, the composite key, and other tables like that, we had composite keys. What we want to do here is that we are going to give ourselves a unique key. Remember, I said that I said replace the composite key with a single primary key. Now remember, I said that we could use a passenger phone number, okay, as a primary key, which was not a bad deal, of course. But now let's say a child grows up and is hasn't gotten a phone and wishes to travel but doesn't have a phone. Some individuals that may not have phones and wish to travel. So you wouldn't say because you don't have any phone number then you're not going to travel. So we have to allow the person give us his passenger ID. Okay, so the person will give the guy a unique ID and register his first name, his last name. If he has a phone number, yes, he doesn't have no problem. Okay, but what we try to do in the company at times is that we try to force people and get a phone number because of ability to communicate with them. So even if they don't give us their phone number, they can give us the next of kin's number. Okay, even if they don't have phone number, in case anything happens, we have someone we call. So what we do is that once you give us your next of kin's number, we copy you can copy his number and place it as your phone number, so that it can help us in case of any emergency to call that person. Okay, or call that person, call you through that person. All right, and then, but to get that problem out of the way, we just have to give a passenger ID, and that solves our problem. No, destinations, we also had from and to. So reduce the complications, because remember we had from and to as a primary key, but sometimes to identify it when we are going to pull it into another table, it may be a bit difficult. So the first thing we need to do is to have we have formed a destination ID here as a primary key. All right, so it now has a destination ID, and then we have a foreign key here, which is the vehicle fleet number. Vehicle fleet number, remember, comes from the vehicle table. Vehicle table had the fleet number, the plate number, the number of parts. We added more. These other 3, 1, 2, 3 are other attributes which we added to this to help this table to be better off. Okay, so we can know the number of passengers the vehicle can carry, the model, then is it air conditioned or not. So a passenger can say, I want to fly in an I want to drive travel with an air conditioned bus. Another one could say, well, it doesn't matter, I need a cheaper bus which doesn't require air conditioning, and they are good to go, especially if you are in the tropics where it rains at times. You don't really need air conditioner, so no need to book for something that will be so cool inside in the vehicle. So we also have the sales person. We now call the table the staff table, and we have the salesperson ID and their first name, last name, designation, and the employment date. So note, composite keys are removed and replaced with unique keys. That's what I just did here. And many-to-many relationships between the destination and vehicle tables. Now you see destination table and vehicle table, they had a many-to-many relationship, all right. And then there's a many relationship between passenger and destination. If we were to do passenger and destination, where I could put the destination ID somewhere here, then we have a relationship that's made, because a passenger can go to any many destinations. Okay, and many destinations can be traveled to by a passenger. Remember that? All right, let's look at how that works. Let's look at a table once to go. You can see from our table here that Magdine traveled to Abuja to Lagos and came back and traveled from Abuja to Abuja to Uyo. So he has traveled many destinations. Okay, at the same time, Abuja to Lagos has been traveled by Magdine, Basibol, Coleman, and Marianne. Okay, so that is automatically many relationships. So that is how we came around about that. So so there's a many-to-many relationship between them, and one of the policies in database, especially relational databases, that you should try to reduce every many-to-many relationship into a one-to-many relationship by using what's called a joint table, or sometimes some people call it a junction table or whatever. All right, so let's have it. Now here's a sample of our tables. Our tables, we have the passenger table here, the passenger table. This is our destination table, the vehicle table, and then this is our salesperson, the staff table. All right, so you can now see everybody's unique. We now give the passenger ID. Magdine is MD, Bibul, K, Rojan. These are all members of the passenger table. We now give destination ABLA for Abuja to Lagos, and ABCA from Abuja to Calabar. All right, they have all been normalized up to third normal form. Now There's what we call fourth normal form, but we are not going to go into that. That is multi-valued problems in fourth normal form, but we are not having any multi-value problems here because every value looks the same. All right, now you watch my video on fourth normal form on how to get from first to fourth normal form, and you'll see where you handle situations like voice call normal form and all that. Now we look at our entity relationship diagram. Our passengers, remember, had a many-to-many relationship, which is divided by M to N with destinations. Destinations had a many-to-many relationship with vehicles, and then staff had many-to-many relationship because a staff registers many passengers. Many passengers are being registered by many staff. Recall on that table, you saw something like that. Because that table, some staff registered passengers for some different period. Like, okay, let's have an example. You have an example here where you had Dean. Dean was being registered by MacDean, was being registered by Alex Allison. Then MacDean was also being registered by John Udo on another journey. So the salesperson, the two salesperson registered one person. At the same time, one person registered many people, like Peter Allison registered MacDean, Bassibol, Coleman, and Mariam. So all those are proof that we have a many-to-many relationship there. So what do? We had broken it down. So that many-to-many relationship we all have here, and we say that the many-to-many relationship should be reduced to one-to-many relationships, and a join or associative table used to link them. That's the best solution. So what do? We have broken down these tables, and we are going to add join tables over here. So you have join tables. So we have passengers to a destination. We have a booking table that will handle them, where the staff is also a member. Remember, the staff was having a many-to-many. So right now, the staff will book passengers to their destinations. He's the one who has a many-to-many relationship with them. Likewise, destination also has one-to-many relationship with vehicle allocation, and likewise vehicles also have. So these are the booking table. And the booking table, we give them primary keys of booking ID and vehicle allocation ID. These are what we give them. They had the foreign keys of their parent tables, which is passenger phone number. Sorry, this is supposed to be passenger ID. Okay, and this is destination ID. And then we have destination ID, and then we have the fleet number as the foreign keys on this table. Okay, now let's take a look at how the table is looking like. So here's the final table, all the entities that we have here. So we have these passengers, destinations, vehicles, the staff, the bookings, and we have the vehicle allocation tables. Okay, so these are all the tables that are necessary. All these 1, 2, 3, 4 are the major tables, and this booking and help to be joined table to ensure that the many-to-many relationship between them has been broken down to one-to-many relationships. All right, now we look at this. We can now see that a table now, booking table, has passenger as a foreign key, passenger ID a foreign key, and they have destination ID as a foreign key on this table. So that long table is brought together here, where we don't need to know our passenger's information. We just put MD in. All this other information is hidden in the passenger table. The destination is ABLA, is hidden. So if we need more details, all we need to do is to look up on that table, and we can use that to print our receipts or invoice or whatever needs to be printed. Likewise, the same thing, the vehicle allocation table. On the various days, you put the date, the vehicle ABLA is being allocated. Vehicle number 121 is told to go to Abuja to Lagos, and he is going to go there on the 12th. Okay, so he has a location ID, and that's how they relate. So they help us to build the one-to-many relationship. Remember, you have here the salesperson. Remember, the salesperson was here. He's also having a relationship in booking. So we had him here, and it comes out here to bring that many relationship come one to many here. All right. So once you're through with that, we go ahead to build our user interface. That's the next step. We go ahead to build our user interfaces using whatever tool we have chosen. You may choose Access. You may choose to use MySQL. Okay. Programming language could be any language of your choice, any HTML, backup or tool, whatever. We are going to deal with that in the next video. For now, we're going to look at the design tools. We have the text boxes here, we have the combo boxes here, have the labels, buttons. We use colors and everything and make the place beautiful and inviting for our customers. So thank you for watching up to this level. The next video we'll have to deal with actually the implementation part, where we talk about the coding. Okay, and that's where we'll be looking at how we'll code with Access, Microsoft Access, and then we'll also code with MySQL and some PHP files, so that you will know how to use all files to use those files to design your own database. Alright, so please subscribe to this channel. If you have a comment, leave a comment. I'll respond to the comment, and also share it with your friends so that they can also understand how we get to design these interfaces.